Welcome back. This is episode 10 of Can I Draw a Triangle? I'm getting kind of hopeful. I think we're close. So if you saw the last stream, you'll know it ended slightly sad. Maybe the move is to go pull the diff up. Let's see what's called Flectris. So we were getting an error about what was it? About ending a recording of a command buffer that wasn't in a recording state. And I couldn't work out what it was, and after a good deal of messing around, it turns out that I was just calling end twice. I think it was just some sloppy copy pasting. So resolved off stream. Because it was not particularly entertaining to watch. I think it was a lot of silent reading before I noticed it. I also just happened to have an internet outage, hence it wasn't pushed up there. So, can I see in here? Yeah, this was the other thing that was an issue. I don't actually know if this was an issue. I was messing around, and I'm not sure if this changed the errors I was seeing. It may have been an issue. So I've moved the start of the render pass earlier, have I? Is that what I've done? And I've enabled local read, dynamic rendering local read, which we might be able to go and disable again. But I don't think that was the key thing. I think the main thing here is in this diff, we've deleted accidental second call to stop recording. So I think just sloppy copy pasting. I've moved it up and I've not deleted the second one, which is why it was in a non-recording state. It had already been ended. So, whoops. I then resisted the temptation to keep fixing things. So I had an internet outage, so I couldn't jump straight back on. So if I just open another thing here up, we'll see we've still got a bunch of validation errors. So we've got a whole bunch of stuff to fix. But before we get to that, I do think that there's kind of two flavors. So actually, having had a look at those things in there to fix, I think most of them are around the options in our like image layout transitions and our color attachment settings, which is all stuff we need to fix. I think it's basically going to be ticking along the through the validation layer output. But I do think I've got a more significant kind of structural issue to resolve first. So I think the first thing to do this stream would be to, I guess, do that. And that is about synchronization. So if you've seen the earlier streams, you'll know my original plan was to kind of ignore synchronization for as long as I could. I think in hindsight that was a mistake. So if I jump down, you'll see here that my main loop draws one frame and then bails. My thinking being, I'll see a triangle flash and then we'll come back and deal with synchronization. This was naive because that was only thinking about synchronization at the level of GPU, CPU synchronization, which is part of the story. We're going to need to do that. But it misses the, I guess, within GPU synchronization we're going to need. So I've had a bit of a read of the docs. Again, unlike previous streams, I've done a bit of homework just to get my head around where I need to put semaphores, where I need to put flags to get a sensible synchronization so that things happen in a sensible order. So if I jump back to the renderer, and I guess let's go find draw frame again. Oh, can I type every time? There we go. And remember, I use snake case. So this is all slightly messy at the minute because I've actually added some synchronization things. Like in here, I've got a fence that I've put on the swap chain image acquisition, which was just not the right way to do this. In fact, that one might be fine. I think it's unnecessary, but it doesn't break anything. I think as I've then continued playing with it, maybe this didn't get committed. I think somewhere I ended up with basically my short-term plan was I was like, okay, screw it. I'll just put fences everywhere that needs to take in a synchronization primitive. I'll make the host wait, and it'll chunk through. And I made a right mess. So I think what we're going to do is instead of that, we're going to do this properly. So if I jump back up here, should we just remove these? Because I think I've just done this wrong. So I think the step one, I think we're going to just tidy up our current program. We're just going to sack off all of the synchronization code I've written so far, which isn't actually very much. So we'll get a nice fresh start, and then we'll attack it with fresh eyes. So yeah, that's what I'm saying. So I think a lot of this stuff is unnecessary. There we go. I'll tell you what as well. Let's write that. We'll do a work in progress commit. So we'll stage that. We'll go work in progress. Remove old messy synchronization primitives. So I don't know what's the matter with me typing. I can't seem to do draw at the minute. There we go. Can I remember how to scroll this to the top? Is it VK? There we go. So the synchronization stuff we need to think about. We do need a fence, and we'll need that to synchronize between the GPU and the CPU. So somewhere we are going to need that. And if I remember right, I think it'll go on our submit call. So all the way down here, I think this takes a fence. No? Eek, maybe it doesn't then. Do you take offense? Yes, there we go. So submit takes offense that it will set to signaled when it's completed. So to do set fence, and then somewhere else, probably at the start of this, we're going to have to wait for fence to ensure the previous frame is finished. So we make a draw call, the GPU's doing what it's doing, the CPU's free to continue working, so the CPU can then chunk onto the next frame that it needs to like compute the game state for. But when it hits this point, we want to make sure that the GPU is ready for us to stick the next frame in before we do anything else, because we've not made multiple copies of all of our different like graphics pipeline. I think we have a graphics pipeline which may be busy, so we're going to wait at this point before we start drawing the next thing. So that's our CPU GPU synchronization. I'm just going to look at my notes and see if I can remind myself. I think, remember right, my plan is to have two semaphores to signal when the thing is done and wait for it somewhere else. Although now I'm looking down, I can only see the use for one of them. No, I think my notes might just be wrong. Okay, great. we can work it out live. My plan with this has been to provide a realistic idea of what going through this Vulkan stuff is like. So I guess this confusion is all part of it. I think the first semaphore we need is on here, and I'm hoping this takes a semaphore. Yes, it does. You can see it there. So it takes a semaphore or a fence. So I think this one was the semaphore, and I need to here have a signal semaphore when image acquired. And I got myself tied kind of in knots here, trying to work out how it's okay to move on past this without using a fence at this point. So I'm not entirely sure. I I think I may have been overthinking it, so we'll worry about it when we get to it. Down here, we then are going to make our record our command buffer. So begin recording, make the color attachment, set up our dynamic rendering. We bind the vertex buffer. These I think are fine, so I don't think these need to have. These memory barriers are where we do our layout transitions for our images. I don't think these need to have semaphores on them. The only thing I was unsure about, is it this? Yeah, this is the thing that uses that swap chain image index, and that swap chain image index is set up here. So my understanding is that we're passing that value in, and we're not passing it by reference, we're passing the value in. When we build these on the CPU side, so that may not be done at the point that we're actually like submitting all of this work. Which makes me think that first thing might need to be a fence, but I'm going to make it a semaphore for now, because I think it is important for something further down. But yeah, so we've got all of that in place. We do our draw call. We end rendering. We stop recording commands. And I think submit info takes wait semaphores and signal semaphores. So I think this will take the wait semaphore to wait to get the image that it needs. And it will take in a signal semaphore so that we can have this, I think, must have a wait on it somewhere. Oh, okay, probably on the submit info. Do you take a wait semaphore? This takes a wait semaphore. So what we can then have is our submit will wait to, is that right? That's not right, is it? Yeah, our queue submission will need to wait until we've got the image acquired, and it will have a semaphore that will signal so that we don't present the image before the image is drawn. Is that the actual thing to say? So you take in, so you have wait semaphores on you. Yeah. So that's it. So this to do wait, let's say semaphore to wait for drawing to complete. And this is a semaphore to wait for the swap chain image to be acquired. And another to signal when drawing is complete. And I think that's all our synchronization that we're going to need. So that's the plan. So toward that, I think we're going to have in here semaphore for image acquired, which we will just bang in like this. We're going to have another semaphore for draw finished. And we're going to have a fence for frame finished. I hope those names are clear, because it's going to be me that struggles otherwise. So, in our init renderer, oops, wrong button. We would like in here to create, can I just call it create synchronization objects? Or primitives, I guess. Objects. And we'll just do a lot of them. So in here, we're going to have so image acquired semaphore res will be equal to, I think it's just called create semaphore, and I should probably go pull up the Vulkan docs because we're going to need them sooner rather than later. Here you can see, this was me reading. Let's do a quick search then for create semaphore. Hope it's fast enough. Need to create info has a flags that's reserved for future use. So, in fact, I think both our semaphores are going to have the same create info. So let's say in here, semaphore create info is equal to vk semaphore create info with an S type of semaphore create info. The other values are all, they're just null values, so that's fine. And then user take, I can't remember what. I've missed it though. Semaphore create info, you take the device. So in here we have our renderer.device. We have a pointer to our create info. We've not got a custom allocator. And then we need a pointer to our semaphore image acquired, like so. And if image acquired semaphore res is not equal to success, then panic failed to create image acquired semaphore. Then we're going to have a very similar block down here for, what was it called? Was it called draw finished? Semaphore. Oh, I can't remember what I've called it now. Let me jump to it here. Draw finished, yeah. So we're going to have here now then, so draw finished semaphore res is equal to create semaphore for renderer.device semaphore create info nil and renderer.semaphore draw finished. And if that's an error, not equal to success, then we panic with failed to create draw finished semaphore. I know this is all a bit wordy, but my plan is to get it working and then tidy things that need tidying. I might regret not tidying up this little sort of pattern here sooner, but I don't know. I think when it's an area that I understand so little, like the Vulkan API, I think it's better to abstract very, very little at first, get it working, and then start shaping it into something that's easier to work with. Alright, so those are my semaphores created. Let's make a fence create info. I'm assuming it'll have a very similar fence create info struct with an S type, which will be fence create info. Let's go check if we've got any things we need to put on it. So hopefully this is the right thing to do. So I guess my worry is if we've not got this synchronization stuff set up, we might be making validation errors and kind of like buggy behaviors that are related to synchronization and not related to the behaviors that we've actually got programmed, if that makes sense. So I think this is the right way around to do it. I'm hoping that the things I'm wiring up are sufficiently simple that either I won't mess it up, or if I do mess it up, I'll mess it up so badly that I'll get very clear like validation errors around synchronization. So we'll see if this all grinds to a halt because we end up spending all our time debugging this because it's all mixed in with the other validation errors we already have. Then we live and learn. But as it is, I think this is the best way to go. So you're going to take here, so let's just say here, frame finished fence res is vk create fence, and that takes our device. Oops, missed the comma. It's going to take our create info. It would take an allocator if we had one, and it takes a pointer to the fence it's going to fill in, and we're just going to check down here. Now, this one we might need to set a thing on, because if I remember right, yeah, so VK fence creates signaled bit specifies the fence object is created in the signaled state, otherwise it is created in the unsignaled state. So remembering that the way we've got this wired in, what we should have is a unsignaled fence at the start. When we get to the start of rendering, we're going to reset the fence to be unsignaled, and we finish the frame, so we finish rendering and presenting, we'll signal it to let the renderer know on the next frame that it's clear and ready to go. So with that in mind, I think we need to set this so it starts signaled. So I think we come in here and we do this one like that, right? And then we'll come down here and we'll just tidy all of those up. So we'll do destroy, semaphore, and at the risk of repeating myself, I think every time I do one of these I say this, but I don't think we'd have any actual bad behaviors if we didn't do this, but I'm hoping by keeping this kind of tidied as we go, I'll avoid having to do a big painful step through everything to work out what needs tidying, when later on we have things that make us rebuild the entire renderer. If we do something like an options screen that lets you swap like really significant things out. So we do all of that. I'm just going to check that we compile. Again, we're going to have a whole load of validation errors, but okay, yeah, that is new because we took the fence out, yeah. So we do compile, so we've not made any terrible mistakes. And now we would like to get back to draw frame. And I think the first thing we're going to do is we're going to have this wait and reset. So it's called wait for fences. It is. Let's do a search in here. Wait for fences. Takes a result. So I'm going to do my same trick of wrapping this into a scope, just so we don't pollute our namespace. What I'm going to say here then, ensure previous frame finished before we start. So res is wait for fences. You take in our renderer dot device. You take a fence count, we have 1, you take a pointer to the fence, which is this. Wait all, makes no difference to us because there's only 1, but yes. And then timeout, I think we want to just make max U64, so I guess there are other situations where you care to time out in like a reasonable time so you can move on and try something else, but as far as we're concerned, this should succeed. If it doesn't succeed, you know, the program's screwed. So we'll just set that to be as big as we can. If res not equal to success, then panic, as always. Failed to wait for fence. So we get to this point, and it tells us that our fence is signaled. We need to set it to unsignaled so that the next time it comes around, it can signal it to tell it when it's finished. So we call this one. Realizing now if we have these in the same thing, we're going to want to rename it. So let's do that now. Oops. So let's have a wait res. And we'll have a reset res, which will have VK reset fences for our renderer. dot device, fence count of 1, and a pointer to our fence. If reset res is not equal to success, panic again with failed to reset fence. This presumably tells us what errors it could get. I don't know if any of those are interesting to us. I can't imagine what would fail other than like a timeout type of thing again. Or maybe if it's not in the right state, maybe if you try to reset it when it's unsignaled, maybe that errors. I don't know. Shouldn't affect us. So we wait for the previous frame to finish before we start. And just to finish that story off, can we finish that story off? We can't finish that story off yet because the fence goes on here. Alright, so semaphore to wait for drawing to complete, signal fence when complete. So that's our whole story when we get to that. Right. So moving further down, our swap chain image. This, I'm hoping, is the field that we need to update. So let me just check on here. Goes timeout and then semaphore. So yeah, I think that's our signal semaphore that we're interested in. I'm just going to go grab the docs in case there's anything squirrely we need to know about. There we go. So device, swap chain, timeout, semaphore. Is a semaphore signal. I do think it's interesting this can take offense. So I don't know if my concern is legitimate. My worry. You see what this does? It takes in a pointer to this unsigned number up here, unsigned integer. Then this integer is then used down here somewhere when we make our color attachment so that we point it at the right image view. So if I pass in a semaphore, do I not pass in the old value of this when I create the rendering attachment? So all my transitions, I think, will happen on the wrong things. I really honestly think they do. I'm going to make a change of plans here. And I'm going to switch that semaphore out to a fence, I think. Because I'm so sure it's a problem. I can't see how that can't be a problem. So I'm going to swap that semaphore to a fence, and I'm going to make a manual like host wait. So what is this going to be? This is going to be wait for image acquired in there. You can go to do add fence. Whoopsie daisy. Which means up here we're going to swap you out for a fence. So fence for image acquired. I'll jump down here. And I guess we'll drag this down to here, and I think this one will also have to be made. This one won't have to be made in the signaled state, will it? So I guess let's stick it in there, and let's rename this. Oopsie daisy. Where have we gone? There we go. We'll rename this one here to... It's no longer just fence. I guess we'll call this the frame fence. Alright, so it's around the entire frame. Whereas this one up here, we will call our image acquired fence. Create info. This one does want to be unsignaled when we start, because we don't want to just start running into this one. You're going to be a fence create info with S type. Fence create info. And I'm going to explicitly set the flags just so I remember that I've done that. And then user become image acquired fence. Image acquired fence res is going to be for creating a fence now. That is now going to be image acquired fence create info. And that is now going to be fence for image acquired. Image acquired fence create info. Why is that complaining for? Syntax error. Because I missed a equals. There we go. Oh, it is not happy with me. So I have typed this wrong as well. And then that needs to be a dot. You are currently pointing at a semaphore. That should be a fence. Thank you, type checker. And then if image acquired fence res is not success, fail to create that fence. And then we bin this one and we have another destroy fence. Okay. Maybe you could do it with a semaphore, but I'm just feeling nervous about it. And this, I think, is guaranteed to work. Well, if we don't make a mistake. This definitely will work if we do it right. Let's say it that way. So, where is draw frame? So now, in this one, we have our unsignaled fence. This will signal it when it's finished. So you, sir, take... Ooh, do you take a pointer or do you take just the fence? Acquire next image just takes the fence. So presumably that's just a handle that, like, internally Vulkan uses to point some area in memory to update the thing it needs. So you take renderer fence image acquired. Once that succeeds, the work is happening. Once the work finishes in here, we will get, in fact, should we bundle it in the same as we did before? We'll have a wait res is equal to vk wait for fences, which will take a device, a fence count, a pointer to our fence, wait for all, and a timeout, like that. And that will block until it either is finished or it fails. So we'll check to see if it failed. Failed to wait for image acquired fence. And just while we're at it, I'm going to make this more descriptive. Just because, I mean, I think with debuggers and things, you can work back from the failed state to find where it failed. But actually, the error I ended the last stream on, where I was just calling the same thing twice, and that was the cock up that caused the error. It's a good example, particularly as you start getting tired, particularly because this is a hobby project I'm doing after work, so I'm going to be tired. It's just so easy to mess that up, whereas if I make these messages really self-descriptive, I found I'm less likely to mess it up. So this one failed to wait for the frame fence. This one failed, whoopsie daisy, wrong line, to reset the frame fence. And then down here, we wait for it. So at this point it is signaled, and we'll have a reset res. Reset fences, which will take in our device, renderer.device, number of fences, and a pointer to it. Renderer dot fence image acquired. Yeah, and again, just boot and braces, check that we didn't blow up. If we did blow up, Kill the program. Failed to reset image acquired fence. Oh, what have I messed up? Reset res. Oops, yep, that's what I've messed up. That is not equal to success. Do all this stuff. Format it. Right. So, we've come in, we've reset our frame fence. We've acquired the image. We've waited for the fence to be signaled. We've reset that fence back to be not signaled. We begin recording. We do all of our drawing stuff all the way down here. All the way through all of this. So we define all our memory transitions. Sorry, our image layout transitions. We define our draw. We point it at our vertex buffer. We tell it how many things are in the vertex buffer. We end rendering to say we're finished with drawing commands. We end the recording of our thingy buffer. We don't need a semaphore anymore to wait for the swap chain image to be acquired, but we do need to have one to signal when the drawing is complete. So, at the risk of being really annoying, we're going to jump back to submit info. We're going to go find our semaphore thing. It's going to be a count and a pointer. That's exactly what you'd guess. We're going to have in here signal semaphore count is 1. Pointer to signal semaphores is a pointer to renderer dot semaphore draw finished. Right. How do you reset a semaphore? Do you not have to reset a semaphore? I think it just takes a signal. It just takes like an event. I hope that's true. That then gets submitted. So I think we now need to go and fill in our queue present so we can finish the synchronization story off. So, which should be kind of exciting, right? Because I think once this works, we will see our triangle at long last, and I will celebrate. I'm actually off on holiday next week, so I'm really hoping to get to the point that we're drawing something before I go off on holiday. I will be kind of glum if we don't get that far. And I think my girlfriend will tell me off if I'm trying to make videos of me doing nerd things while we're meant to be relaxing on holiday. So there will be a hiatus, whether we like it or not. Maybe I would have been better off searching for this manually. This is a lesson I've learned, though. I think once you've told it to search, it will jump. So, there we go. You are very simple. You just take... Oh, okay, I need to define your queue info. Okay. So, down here, let's have... We've got the submit info, queue submit. I'm surprised if that doesn't return a result, and it does. Okay. So, let's do our normal... bit of stuff in here to say so we're going to submit our commands. You also return a result, so we're going to have a bit of namespacing. Present images. That was my issue with it, is that we've not got the res on there, we've not got the res on here. If res not equal to success, panic, failed to submit, failed to submit command. Then down here, we're going to need to have a present info, will be equal to a vk present info khr. We'll have to fill that in. Then this takes a queue that it's going to submit its request to. We only have the single queue, so that's easy. It'll take a pointer to present info. which is easy, and then if res not equal to success, panic, failed to present image. Right. Let's go see what goes in here. There's a bunch of stuff, but it's almost all about weight and swap chains. So we've got all of that in place. So hopefully easy stuff. Present info KHR. Pnex we don't put in unless we need it. Weight semaphore count will be 1. Pointer to weight semaphores will be a pointer to renderer.semaphore draw finished. So we will wait until draw finish signals to say it's finished before we try to show the image. Our swap chain count is 1. Our pointer to swap chains is whoopsie daisy. It's going to point back to our renderer swap chain. Our pointer to image indices. Oh, interesting. I wonder when you'd have multiple swap chains. Is that if you were like rendering to multiple devices at once or something? Okay. Pointer to image indices is swap chain image index because we only got the 1. Oh, fun. It doesn't return a result. We get a pointer to results. Applications that do not need per swap chain results can use null for p results. Okay, yeah, so we don't need this. This is if we had multiple swap chains, we need to know which one failed. We don't care because we can do it on the queue present. So let's put it in just so future us remembers it's here, but we do not need it. So we do that. It presents. If that, it fails. Check it runs. Nice. And so if I've understood things correctly and I've not made any mistakes, that's all of our synchronizing done. We've even kind of, sort of, I guess, like belt and braces, safety coded this for ourselves. With using 2 fences instead of using 2 semaphores. Maybe it would be fine because the fact this is a pointer back to that other thing, I guess means if it was not done by the time it got to here, we will have waited for it and we would get the right number. But again, the thing that worries me is this one in here doesn't take a pointer, right? This one in here takes the value of swap chain image index when it's defining the transitions it needs to do. So the thing that worries me is that if we use a semaphore, the point we're making these, we've not waited for that semaphore. So I think this might get the previous swap chain image index. Then the swap chain image index would be updated. The image transitions would happen on the wrong thing and we wouldn't be able to present. I don't know if that's correct, but it's what's got me worried. So we've used 2 fences and a CPU wait, which is probably bad for frame rate. I guess that's the thing to say is I think fences are probably worse for performance because you're making the host block to wait for a thing to happen, whereas semaphores are just signaling within a GPU workload. So that's probably preferable, but super simple, super dumb. Let's do a commit there. So what are we up to? Work in progress. Synchronization done. Still got error and validation error layer warnings. So let's bang that in because I think that's a useful spot to get to. Right, let's have a look at these then. So it comes up and it crashes. So we are going to have to deal with these. I wonder if the best thing to do, let's move that off to a different screen. And I might run this in 2 panels next to each other rather than how I've got it, just so I can see them both at once. I'm just going to keep an eye on the stream and see if this looks readable. Yeah, I think that should be alright. So Odin run main, we get our error out. So where are we? Command, pipeline barrier, source stage mask, top of pipe. So this was a bit of a guess when we got to this, wasn't it? So this one is for our memory barrier to write. And then we have memory barrier to present. Yeah, so we've got one image transition we need to go through before we can use this thing as a color attachment. We're going to go from an undefined layout to a color attachment optimal layout. And I have tried to do it so that the source stage is top of pipe. I think this can actually be fragment shader. So as it comes into the fragment shader, it will know that it needs to do this. I think this is complaining source stage mask is restricted to frame buffer space stages, which means fragment shader, early fragment tests, late fragment tests, or color attachment output bit. Right, so let's clear that and rerun it and see if that one's gone. Nice. Command pipeline barrier must contain VK dependency by region bit. If VK command pipeline barrier is called within a render pass instance and the source stage masks and any memory barriers include frame buffer space stages, which is what we've just done, then dependency flags must include VK dependency by region bit. Is that a source access mask? No, dependency masks. Is that down here? Dependency flags must contain the by region bit. So we come in here, we clear, we run it again. Nice. Where are we now? Command pipeline barrier, old layout, P image memory barriers, defines image layout from undefined to image layout color attachment optimal within a render pass instance, which is not allowed. The Vulkan spec states, if this is within a render pass instance, the old layout and new layout members of any image memory barrier included must be equal. Ah. Interesting. I thought that there was a thing we'd enabled that allowed us to do this. I guess not. Well, how are you meant to do it then? Objects 2, command buffer and image. The old layout and new layout members of any image memory barrier included in this command must be equal. Defines a layout transition within a render pass. Because we've got the two commands and they're inside of a render pass. I don't suppose it's going to be as simple as I need to move this before we start the render pass. That feels optimistic. But who knows? Come in here, jump up, jump up. Oh. Okay. There's no errors. We will take that. So it was that. That's interesting then. So I guess you have to define these barriers before you begin the render pass. Because they happen within the render pass, right? That's not controversial. Inside of here, it's doing it, well, in this case, at the fragment shader. And in this case, as it goes from fragment shaders to color attachment output. And I guess it must be working, so otherwise it would be blowing up on the submit, right? If this weren't in the Oh, where am I looking? Up here. If it didn't make the change to present source layout, we saw somewhere else that it will not let you do the thing. I am slightly confused that this has a destination access mask for that, because I don't think that is actually what it's doing, right? Because it's no longer a color attachment. Is one of these about presenting? They don't look right, do they? I wonder if that can just be nothing. Maybe. Okay. Let's do a commit to say here. So fixed validation layer warnings. Oops. Commit fixed validation layer warnings. And let's go back to main.main Odin. Maybe here, instead of breaking, can we just while true? So we've got black. We haven't actually drawn anything. Okay. And we also can't end it because we're hanging. Interesting. What do we do with that then? Draw frame. I mean, if it worked, it would definitely show it there. I guess one thing that might be worth us doing here would be to go and check our cull mode. Is there a none? I guess none is just passing nothing. If we don't cull anything, so my thinking here is maybe I've done this wrong, I've thought about it wrong, and my triangle is the wrong way around. It's not that. Okay. And remember, you can't kill it with the actual commands. So that's worth leaving there. Right. So this leaves us in a slightly painful position. We now need to step back through this and work out why we're not drawing anything. I'm trying to think if there's any other really obvious places to look. Pipeline layout. And the pipeline stuff seems one obvious place. This might be a good time for us to pull up render doc and just check that we are seeing our vertices turning up and whatever else. Create the graphics pipeline. Okay. Let's do that then. So let's come back to here, and instead of doing that, we're going to make a build main tick debug. And we'll go find a new space, and we're going to run render doc, which is probably going to have a load of stuff that's too small to really see. So sorry about that. But we can now pick to run main bin in Flectris. We would like to capture frame 0. Why did you? Seem like you didn't work. Can I just run main bin? That does work. If I come back to here though, let's say launch, it then doesn't work. Actually, thinking about it, I don't need to do that blocking, do I? Because we've done all of our... The reason that I wanted to only do the one frame is that we weren't going to do any synchronization. I was trying to make things simple. But now we've got our synchronization, so I think this can actually just charge around and round without issue. So let's go and build that again. So there it is. It is still blocking, interestingly. So just to check. Yeah, we've taken that out. Can I just stick a print in the top of this? So, just to check we are calling this over and over. So, print line, draw frame, and take that out. So, if we now go Odin build We run this. Ah. We draw two frames and then we stop. And we are now just broken. That's interesting. Did I mess up by not putting a fence on my thing somewhere? Q present. Can you take a fence? S type, P next, wait. You can't take a fence. That is interesting. I guess the fence needs to go on this one then. Because we have... Okay, yeah, I think that does make sense. So, way back, I don't know when, in one of the earlier streams, when we set up the swap chain, one of the things you have to do is you have to set up how it will handle queuing. So you can keep submitting images to it. I think we've set it up so that if we get the preferred settings, if the queue is building up, we'll start dropping earlier frames to put in the up-to-date frames. Which means we don't actually need to synchronize on that. Does submit info take a fence? Can we jump to it? Is this going to be reasonably quick? So I'm just going to have a sip of my drink. Oh, it's not quick, is it? And again, once you've hit the button, you are kind of committed. Oh, that's a point. Do I need to call it like Q submit info or something though? No? Alright, let's look for Q submit instead. Because there's going to be a whole bunch of like things submit infos otherwise. Let's jump to that one and hope that just straight Q submit is underneath it somewhere. Submit flags, semaphore info, submit info. There you go, submit info, which will take somewhere in here will be a... No, this is submit info. You also don't take a fence. That seems really surprising. Ah, Q submit takes offense. So if we jump back, where's our Q submit? Yeah, there it is. Okay, so you renderer dot fence frame finished. We come back, we build it, we main bin it. Okay, so we're not drawing anything, but we are we are calling draw frame a lot, and we can close the thing. Okay. So let's put that in. So debugging, no triangle showing, but at least we have a working render, a working. I'll quit main loop. It's the little things. Okay, now will render doc actually capture us a thing. So come back. So that was running main bin, was it? Or did I do Odin run? Yes, that's running main bin and it's working. We come back to here, we grab main bin, we're going to queue and capture frame 0. And it didn't capture anything. Damn it. Because that breaks it? No. I wonder if it can't find the shaders. Does it have like a... Yeah, it does have a working directory. Although I think that's what it was defaulting to. There's kind of nothing else obvious to put in there, is there? When I go looking for shaders, what is my path that I give it? In fact, actually, so yeah, you're running from Flectris. Is it worth maybe if I run render doc from here, just to be really certain about where it is running. I'm going to close the other one so I don't confuse myself. And actually, let's move this one to there. We will run main.bin from here, allow full screen, allow vsync. I don't think any of these should be problems for us. Okay, cool. So I think that was the problem. So let's capture a frame. Cool. Is our load thing going to be bad? Because load don't care. It says it's just looking at, like, nonsense memory, doesn't it? So yeah, we've set something up wrong. I don't know, though. Can I see my vertices coming in? There's no resource. Goes to the rasterizer, so it's also getting no vertices passed in. Or am I just looking in the wrong place? We come back to here, we begin rendering, we make... Hey! Okay, so our vertices are getting in. And we can see that we've got our positions are making it, our colours are making it. Right. So that is progress, that's good news. So yeah, we can see there, vertex input. Cool. Vertex shader. So we could jump in there and look at it and step through it, but I don't know that's useful to us. I don't think we're doing anything that's an issue there. The fragment shader. And then it gets through to the frame buffer, which are both none because we're doing dynamic rendering. I don't know what CS stands for. Okay. Okay. Well, what can we say from that then? So we're happy our vertices are making it in. We are making a successful draw call and submit call. So it does look like it's something in our load op, store op stuff that we've messed up somewhere. Did I just kill this? Let me kill this. I'm not going to save the capture. We can make another one if we need to. Right. Can we go look for load op? So we have color attachment, load op, renderer, swap chain images, color attachment optimal. Resolve mode, I think we were pretty sure it's not that. So the only thing I can think it might be is clear. Right, so we go to a clear colour. Tell you what, we'll make the clear a nice, horrible, like, bright magenta colour. And that'll tell us, I guess, if we are actually clearing the image as expected, or if we just get the same, like, nonsense, then that tells us that I guess these are more broken than they looked. So let's go Odin, run main. And we are getting pink. Okay. This is good. So, coming down here, color attachment is this. Was there anything else that could go into store op? None don't care or store. We do care, so we're going to have store. Color attachment optimal. Clear value, sub-resource range. Base MIP level. And I'm fairly confident these must be working, because otherwise... Is it that this needed to have color attachment read on it or something? We took that off. No, it's not that. So you have an image on you, you have a sub-resource range, command pipeline barrier. Ooh. Alright, just because it's going to confuse me, I'm going to move this one up so that they're next to the config that they're being applied to. So we have our memory barrier to write. It's an image memory barrier that we must be able to write to from a shader. Let me just check. So is this actually meant to be a color attachment write? Maybe. In which case, I think that might be able to go, but I think that might need to be a color attachment write as well. Well, it didn't make things worse. Let me just check I had it written. Yeah. Okay, we might have to go back and look at the docs, because I'm not sure what's meant to be in those. Is there anything else that uses a load up or store up? No, so that's our one place in the color attachment definition. And like I say, at this point, we have waited for certain. We know that we acquired the next image and it finished. So there's no issue that we're looking at the wrong image. How funny it would be if that actually is our issue. Alright, I'll tell you what we're going to do. Is we're going to put that through RenderDoc again. Now that we know that the clearing is working. I think we did fix something. I can't remember what it was. Let's run RenderDoc. And we'll relaunch. Oh, same thing. Ooh. Did I not build it? Odin build main debug. So user can run main bin. Is any of the rest of this useful? Can I just be like, collect everything? Verify buffer access, auto start, queue a capture. There we go, so we capture the first frame. And just for sanity, we come in here and we can see our triangle is making it in. God, this just sucks. Okay. So it does make it in. There's no geometry shader output. So our vertex shader output is these 3 points with those 3 colors. What can I see? What does this tell me? The rasterizer. What do you mean it has depth clip? Because I haven't got any depth information. Well, I'm also interested. Can I see what these issues are? Not sure where I would see them. Symbols not loaded. Resolve symbols. Okay, whatever. Okay. This has me suspicious. But I actually don't know. Would it be in here? Rasterization state. Do you also have a depth clip? You have depth clamp enable. Rasterizer discard enable. Front face. Depth bias is disabled. Depth clamp is disabled. So what is depth clip? Can I find it in here if I do depth clip? Slightly optimistic. Have another sip of my drink while we wait. Okay, that was probably an error. Let's have a look. Is there anything in here about depth? Or else it might be under the rasterizer. Hey. Depth clamping state is changed dynamically and the pipeline was not created with that thing. Depth clipping is enabled when depth clamping is disabled. Oh, okay, then interesting. So you always get one or the other. Maybe we want to enable that then. What actually is depth clamp? Is there a thing in here to jump to depth clamping? To dynamically set this. Pipeline dynamic. Otherwise it's specified back on here. Depth clamp enable controls whether to clamp the fragment's depth values as described in depth test. If the pipeline is not created with this extension present, then enabling depth clamp enable will also disable clipping primitives to the Z-plane of the frustum as described in that. Maybe we enable this. So we've disabled it thinking we make life simple. I don't think there was any like deep thought went into that. I don't know if I need to set something to tell it like how I want it clamped. Depth clamping. The rasterization tape is enabled. This gets clamped to Z min, Z max, where these are the min depth and max depth range values of the viewport used by the fragment. So they come back to the viewport, which is up here. So can I jump onto this? You take flags, viewports, and scissors, and these do take depths. Okay, we're getting somewhere. So when we make you, we set min depth to 0 and max depth to 1, which again would have just been because they felt like sensible numbers. But maybe that's fine. Okay, so we've now enabled that, so we're no longer doing clipping, we're just leaving it. So ours should all just sit at 0. Right, so that's the change we've made. Still no triangle. But if we now come into here and we run this, don't save the capture, we get rid of the U, we look inside our drawer, our triangle is there, and if we start querying in here, we can see the depth clamp is enabled. Okay. Scissor regions. We have a render area from 0, 0, width and height. Slot 0. I don't know why there's 2 of these. I don't know if that's a worry. So there's our viewport. I mean, there's nothing to tell me what the output of that is, though, is there? I don't know what it would give me. We're looking at in here, there's an export. There's extensions, we've not got any. Okay, so this just tells me all of the I don't know what it tells me. So our fragment shader is a load of spurvy, like, intermediate representation stuff that means nothing to me. This doesn't tell me anything, presumably because it's all in dynamic state. So like I say, we can go and see, we have a graphics pipeline that we can see as a parent, as a pipeline layout, a shader module, pipeline layout. I don't know if you have anything interesting on you. You have a create info, flag bit 0, set layout count 0, you have a layout. Okay, so yeah, you don't have any push constants. So we've got a bunch of swap chain images, semaphore, physical device. Yeah, no, I just don't know. I don't know what you actually look at for this. Your command buffer. We've got our vertex buffer. We've got our command buffer. Command pool allocated it. Our device. Our 2 fences. We have a graphics pipeline. I mean, this all feels very much like... why is there only 1 image view when there are 4 swap chain images? We have 1 image view for just the first one. Is that a cock up? Have a look. Swap chain image views. Where are you used? You're being destroyed there. At this point, we're just grabbing one. Okay. I don't know why there's only one in that list. But I mean, this looks like it's doing the right thing, right? We've got more than one swap chain image, and we are creating an image view for each one. For I in 0 to the length of swap chain images, we create it. Create image view. Insert to I. Yeah. I mean, it looks sensible. That's our only thing that seems weird so far. Memory, physical device. Huh, why are there two physical devices as well? Ah, okay, so we'll only be using one of them, right? Let me create instance, but it's my computer has both the CPU bound like driver and the integrated GPU bound driver, so I guess that's why there's two of these. With our pipeline layout, we've grabbed a queue. I don't know if this will tell me anything about it. No, it doesn't look it, is it? Our semaphore, we have our two shader modules, so we can see all of our code is getting up there. I guess the next thing to do would be to compile our shader code with debug symbols and step through it maybe. I do want to see, is there any way to see these? Aha, there is. Okay. What can you tell me? You're in miscellaneous, severity is high. Oh, is there any way to make this so I can see it all? Pointer to image memory barrier, destination access mask, color attachment right bit is not supported by stage mask, pipeline stage fragment shader bit. Any element of this thing, if it's source queue, family index, and destination queue, family index, members are equal, or it's destination family index, the family index used to create the command pool. Dest access mask member must only contain access flags that are supported by one or more of those stages. Right. Okay. What does that mean then? We said something wrong. Color attachment right. So you can't be that. Means you can't be that. What if? Oops, sorry. Let's Odin run main. Okay, so that didn't fix it, but we got rid of that. I don't know. Okay, let me get rid of the draw frame printing, because I think if it was outputting anything useful, we're just drowning it at the minute, aren't we? So Odin run main. Yeah, okay, it was telling us stuff and we're missing it under all of the draw frames. Okay. Depth clamp enable is true, but depth clamp feature was not enabled. If the depth clamp feature is not enabled, depth clamp enable must be false. Okay. And then signal semaphores being signaled by a queue but may still be in use by swap chain. Okay. Let's do them in order, because it's the order it hits them in. How do I enable the depth clamp feature? I mean, that makes me think that we should just make it false, right? Because we're not actually using that feature anywhere. I was just kind of messing with things I didn't understand. Yeah, so we got rid of that one. Clear this. Alright, so what is this saying now then? So, Q submit signal semaphore. Q submit. Ugh. Q submit info has a signal semaphore draw finished. P signal semaphores is being signaled by VKQ, but it may still be in use by VK swap chain KHR. Here are the most recently acquired image indices 0, 1. Brackets mark the last use of the semaphore in a presentation operation. Swapchain image 0 was presented but was not reacquired, so VK semaphore may still be in use and cannot be safely reused with image index 1. One solution is to assign each image its own semaphore. Here are some common methods to ensure that a semaphore passed to VK present KHR is not in use and can be safely reused. Use a separate semaphore per swapchain image. Index these semaphores using the index of the acquired image. Consider this extension allows using a VK fence with the presentation operation. The Vulkan spec states, do I understand what that's saying? We've got our fence around the whole thing, but like we say, it's separate from this, right? So we've got no way of knowing in here that this is finished. So what is it saying? It's saying that its wait semaphore is in use on index 0. But we're properly calling the acquire thing, aren't we? So what is it saying? It's saying you could just have a signal semaphore per swap chain image. Okay, let's see. Have I got any changes I would like to save? Let me have a quick look. Sorry. So that I do want to keep. That I quite like. That I think was a good change. That seems like it's fine. That just moved. Yeah, so I think I do want to keep all of those. Work in progress. Debugging why our triangle isn't showing. So, where would we be looking? There's a better way to do that. So it's saying in here, instead of semaphore draw finished, what I can do is I can have a slice of these, which I will call semaphores draw finished. And in here, instead of creating one of these, I'm going to say that renderer.semaphores draw finished is equal to make a slice of VK semaphore with the length of renderer.swapchain images, which might need to be cast, doesn't. And then for I in naught up to less than len renderer swap chain images, we will do this a bunch of times. And in here we'll have semaphores I. So we're going to make a new semaphore for each swap chain image. If draw finished semaphore res not equal to success, can just stay like that. We only need this one fence, we only need that one fence. And then in here, we'll have to say for nor in less than equal to len swap chain images. Does that not work? Why is it upset? Right. It crashed. Okay. For naught in that range, we're going to destroy the semaphore. For semaphores, draw, not 6, sorry, I. Let me close and reopen it and see if that gets the LSP back. It does. Oh my goodness. Caxi Flectris. Go to renderer. There we go. Interesting. Disabling hooks for this buffer. Please report the image. Panicked. Invalid params. Huh. Okay. No, it's just broken. We broke OLS. What are we doing in here then? So we're going to do that, and then we will delete semaphores, draw, finish, just tidy the memory up. Then let me do a search and find. We're going to have a bunch of these now. So you're no longer this, you're now swap chain image index. I wish it would stop telling me that. And you no longer wait on that, you now wait on swap chain image index. To do semaphore to wait for drawing to complete, signal fence when complete. You, sir, have a semaphore for when you're waiting, so that's actually done, right? So it wouldn't be that, it'd be that. Delete it, delete that. Can I please do a clear and rerun just to see if it will compile? It will not, because that's a syntax error. Is that what crashed it? Really? I in all of that. That needs to say swap chain images. Odin run main. Still no triangle, but it will build again, and we're not getting that semaphore thing again. I'm going to reopen that just to make sure my thing is working. Right. So where are we up to then? Let's see if we fixed that warning, and then we'll see if we can unpick anything else useful from RenderDoc. So we launched the application, which is out of date. Thank you, RenderDoc. Odin, build, main debug. Actually, something to do is probably rebuild our shaders. Can I remember the call? GLSLC. Is it -G? Let's hope. GLSLC. That's frags. Let's do vert as well. Then let's build. So we've now got debug symbols and everything. And now RenderDoc can load this, and we can step through our shaders and actually see what's happening everywhere. So it will capture a frame. No problems detected, so that's good. Let's run our same sense check that we've been doing. We see our mesh viewer. We have a triangle with colors being passed in everywhere. Vertex shader output has 3 vertices. Each of them has a color, which is good. So now we can have a look And we should be able to step through this. Nice. No, I guess we're not able to step through it because we've captured a frame. We're not like live running it. Does this tell me in here? So I have an input signature with an in position and an in color. And a GL position, which is a float for position, RGBA, RGBA. Okay. Don't know if that is useful to me. But anyway, so that's the vertex shader running. We then have our rasterizer running. We have the fragment shader then. Again, I can see a pipeline layout. I don't know if that's useful to me at all. It doesn't seem it. I have my fragment shader. I can view it in here. It has frag color, out color, frag color. I mean, there's no useful information in there, is there? What do these things have on them? End rendering. Instance count, first vertex, first instance. No call stack available. Is there a thing in here so you can... Aha. So where am I looking? Text before, text after. How do I change which pixel I'm looking at? Really, I want to look at the pixel right bang in the middle because that's... Aha, okay, right click to pick a pixel. Show me its history. Color pass number 1, 1 targets, event ID 10, command begin rendering clear, which makes it the pink. 1 fragments touching pixel. Then our draw. I mean, all this tells me is that it... Ooh. That's interesting. So if I pick a different point in here, and I ask for its history, and I'm getting different colours. My triangle is in there. It's just... Oh, did I pick a point that isn't in the triangle? Texture before, texture after. Where else would be in my triangle? Color pass 1. Okay. So they've all missed the triangle. These two very clearly end up getting colours out of the shader and ending up not being written properly. Oh, what could be doing that? So I guess it could be our load op store op being wrong, right? That's like actually how our color attachment thing is getting written. I mean, is it something about these access masks? So in this one, should I go and have a look at what these access masks actually are? If I go look up image memory barrier in here, I think because memory barriers like a whole chunk, yes. And inside of you can say, so memory barriers are used to explicitly control access to buffer and image sub-resource ranges. Memory barriers are used to transfer ownership between queue families, change image layouts, and define availability and visibility operations. Availability, visibility, memory domains, and memory domain operations are formally defined in the availability and visibility section of the memory model chapter. Which API operations perform each of these is defined in this. A memory dependency is an execution dependency. Includes availability and visibility operations such that the first set of operations happens before the availability operation. Scoped ops, mem ops, access mops. Sorry, access scope, scoped mem ops. Oy. Okay. Image sub-resources can be transitioned from one layout to another as part of a memory dependency, e.g. by using an image memory barrier. When a layout transition is specified in a memory dependency, it happens after the availability operations in the memory dependency and happens before the visibility operations. Image layout transitions may perform read and write accesses on all memory bound to the image sub-resource range, so applications must ensure that all memory writes have been made available before a layout transition is executed. Available memory is automatically made visible to a layout transition, and writes performed by a layout transition are automatically made available. Layout transitions always apply to a particular image sub-resource range and specify both an old layout and a new layout. The old layout must be either that or match it. If the old layout matches the current layout of the image sub-resource range, the transition preserves the contents of that range. If the old layout is undefined, the contents of that range may be discarded. If the contents of an attachment are not needed after a render pass completes, the application should use store op don't care. As image layout transitions may perform read and write accesses on the memory bound to the image if the image sub-resource affected by the layout transition is bound to peer memory for any device. The current device mask must support this. I think that's a device group thing though, so that's not us. Layout transitions that are performed via image memory barriers execute in their entirety in submission order relative to other image layout transitions submitted to the same queue, including those performed by render passes. In effect, there is an implicit execution dependency from each such layout transition to all layout transitions previously submitted in the same queue. Image layout of each image sub-resource of a depth or stencil image created with that thing is dependent on the last sample locations used to render the image sub-resource as a depth or stencil attachment. Thus, when the image member of an image memory barrier is an image created with this flag, the application can chain that thing in pnext to specify the sample locations to use during image layout transition. Pipeline stages. The work performed by an action command consists of multiple operations which are performed as a sequence of logically independent steps known as pipeline stages. The exact pipeline stages executed depend on the particular command that is used and current command buffer state when the command was recorded. Several of the synchronization commands include pipeline stage parameters restricting synchronization scopes for that command to just those stages. This allows fine-grained control over the exact execution dependencies and accesses performed by action commands. Okay, can we just check then? So in here, what have we got? We've got a memory barrier to write where we are saying, is color attachment the wrong thing here then? Should you be a shader write, shader read optimal, fragment shader rate attachment? Destination access mask. Is this something I had and then it blew up for some reason? Yeah, I didn't like that. It's not supported by the stage fragment shader bit for any element, so yeah, that's not the right thing. Shader right sounds like what we want, doesn't it? My god. Back. Put that in. Which again would mean in here, I want shader right. Clear. Let's do it with Odin run main, because otherwise I'm gonna forget things. Okay, so that runs but doesn't actually show me anything. And then this one, do I put something like that in there? No. I'm still not sure I understand what this is actually about. I'm just going to skim down this and see if there's anything really obvious that jumps out. I kind of thought there'd be one of these that was like very clearly input attachment read. Was going to be very clearly about presenting to the screen, but there isn't really. Yeah. Okay. I think I might go and look at an old project that I've written that does something similar to this and just see what the image memory barriers on it look like. Which, you know, there's always been an option on the table. I think when we've done these streams, I've always said we're going to start with memory and the spec as an attempt to try and like ingrain this into my head a little bit more. But I have followed through tutorials before, and so I've got working programs that do stuff like this. So let's have a quick look back at my Brachy platformer example. I'm going to do it in NeoVim just so that the colors are different and it's easy to tell one from the other. Where would this be then? Can I look for, I guess, pipeline barrier? There we go. So pipeline barrier goes from source stage. Ah, okay, so we wrote a helper method for it in this. Temp. Ah! It did it as a separate command that it would do. Which I think I did consider, and then I didn't do. So what are these doing? Shader read only optimal. So this is slightly different because why? So apparently we were doing stuff for, what does that say? From undefined to transfer dest. Ah, so this isn't actually about the swap chain images. This is going to be used for the what's it? This is being used for texture images, right? Which is why we have a transfer as we put it onto the fast memory on the GPU. Another one as we go from transfer to shader read. So that isn't what I want. Copy buffer to image. What are you doing? Create texture from file. See, this is the problem going back and looking at these things. They're not doing exactly the same thing. So what actually am I interested in? I guess it's our draw frame. Unless maybe this one's doing it. So you have format, old layout, new layout. No, that's what I was just looking at. Okay, let's see. Do I have a draw frame? I do have a draw frame. Inside of that, do I have like a begin command buffer? Reset command buffer, reset fences. Yeah, so like this one here you see is doing this all with semaphores and not with the fence. So actually maybe that is just wrong. And I am doing that in a silly way. Okay. We'll worry about that later. Reset fences, reset command buffer, begin command buffer, begin render pass. So again, this is all being done in the old-fashioned, like non-dynamic rendering way. So it isn't one for one. Intrinsics, mem, copy, non-overlapping. So yeah, we're getting our render data in. Index buffer size, does another copy to get that in. It gets the vertex buffers, which we then bind. We bind index buffers, it makes a viewport. This one uses dynamic viewport and scissor, so it has to set them. Bind descriptor sets. Am I doing that? Descriptor. Sorry, let's do the descriptor set. I'm not calling bind descriptor sets. Okay, and what does that have on it in here? It has our pipeline layout. We definitely have a pipeline layout somewhere in here. So I guess where are you then used? You get made. You're passed into the graphics pipeline. Okay. So there's a difference. Right sampler. Okay, so we don't have a sampler yet, so that's a reason why we've not got that. That's allocating it. Descriptor right sampler. Right. Color attachment description. That sounds promising. Can we go find our color attachment description? Color attachments. Somewhere up here we have our color attachment. These things are different, but a lot of the values on them should be the same. So format. The hell is format? Oof. So load op, clear, store op, store. Yes, that's what we were thinking. So that matches up. Initial layout, final layout is present source KHR. And then present info. Looks kind of as expected. Yeah, that's all it has. Attachment ref has a layout of color attachment optimal. Subpass. Yes, this is the stuff that's all different, right? And then these have the things in them. Ah, that looks somewhat familiar. So actually in here, where before it was defining a subpass dependency, source subpass, dest subpass, source stage mask was color attachment output, dest stage mask, color attachment right, render pass create had that on it, and it points back to that attachment. So are we just using the wrong stage masks? What is that actually saying? Oh, I've lost it now. Where was it? Source stage mask. Dest stage mask. So on color attachment output. So it's not in the fragment shader. It's saying on color attachment. No. Sorry, you are saying on color attachment output. And then instead of shader right, I want the color attachment right. And then source shade mask. There is no... Okay, so they both have the same thing, and then that one has nothing in it. Is that going to be it? No. Okay, so that's not it. But it has to feel slightly better that they're similar. So subpass dependency. It's saying in the color attachment output, we want to make sure that we're in a state where we can do the right, which makes sense, right? So in color attachment output, we need to transition the images from who cares to color attachment optimal. Which is this. Yeah, okay. Which makes me wonder down here then. In this case, we're going from color attachment optimal to present source. I'm going to take this one here off. I wonder what the right destination stage masks to use then is. So in this case, we're going from color attachment output to something. I don't know what. Is it bottom of pipe? Just say like once we're finished. Draw indirect fragment tests. Geometry shader host. Top of pipe transfer. Or we tell it to do bottom of pipe. So we're saying when we get to the end of our what's it? We get to the end of the pipeline. Nah, it didn't do it, did it? Okay. Well, it didn't break anything. Let's see. So I think that is a useful little reference for us to keep. Let's do an Odin build main debug. Don't run it. Jump back to render doc. Let's jump to Hue. We will launch the application. Main bin. Flectris. We launch. I wonder if you can actually stick a debug point inside of your shader. So you're doing things, we have a pipeline state, we have a vertex shader that we can't see because we've not captured a frame, I guess. So like, what could it do? Is there like a resource viewer that we can use to go and directly poke at a shader? Launch application, Python shell, event browser, API inspector, mesh viewer, errors and warnings. Errors and warnings, none. So that's nice. Statistics viewer, resource inspector. Resource inspector sounds promising. Let's go look in there, but again, we've got nothing captured, so it doesn't know what to do. So, let's go capture a frame, I guess. Oh, where's it gone? You in here. We capture a frame, we come back to here. Open in, rename capture. Capture after delay, I don't know if any of this is useful to us. No resource, because it's not on anything. We open that one up. Blend factor, depth state. Nah, I've got no idea. I guess what I was hoping to see is a thing that would be like, yeah, you can step through your shader and see the different numbers coming through. I'm sure you can do that, but I don't know where I need to go looking. So in here with vertex shader, frame buffer. Oh, let's see, we need to be in here, we need to go to draw. We have swap chain image, texture is in, layout, present, usage in frame, barrier, discard, barrier, clear. What does that mean? Frame buffer color. And then present. Down here with swap chain 93 is the swap chain, not the swap chain image we're presenting. Image indices is 2, which is this one. It did have the swap chain color written to it. Sorry, the frame buffer color written to it. I mean, I'm assuming we're getting at that exact same thing we had before, right? Which is we can see our triangle here. And if we do that thing to see the history on this, it is getting a value set, it's just not staying there. Right click to debug an event. Ooh. Debug pixel. Can I see it in here? And so what did you get? You got passed in. I don't know what to say of this. Is it frag color, which is the value we passed in. The values 0.22 something, 0.42 something, and 0.34 something. And the values out at this point are all massive. Is there a button to say like step? Execute backwards or execute forwards? Step forwards. Yeah, so they all just become those values. They all go into a register. And then we're outside of this, right? So what does that mean? It means it's fine at this point. So it's something here is where it goes wrong. Swap chain image is in this format as an out color. Depth state. Bounds, target blends, swap chain image. I kind of wish there was a way to see what it looked like. Well, I mean, other than the fact we can see here that our shader output is some value. I wonder, what does this say? Pixel values. It's not that it's just tiny, is it? Because, like, we're not seeing anything. We can see very clearly in here that the shader out and text out is, well, terrible. What's this set up here? Usage for the swap chain. You can see it has two barriers. So there's a barrier there. Swap chain image is 97. So can I see that in the resource inspector? Swap chain image 97. At this point, can I see what your format is or anything like that? So there's your swap chain image index. What does this say? Pipeline, color attachment output bit, dependency by region, memory barrier, VK memory barrier, the pointer to this that says it wants to have a color attachment right, and it's going to color attachment optimal. The sub-resource range. Hey, maybe this is the thing to go and check. Maybe I need to just go read these docs again. I must have missed something. VK image aspect color bit. But then the alternative are things like depth and stencil, which is definitely not what we want. I don't know what this discard here is about. And then it clears it. And then we write to it. So this barrier is our barrier where we're setting it into... Do I just need to move that? Am I just doing that in a silly place? So if I take this... I can't just move it, can I? Because it needs to have this as well. Do I have any other changes I care about? Yes, I do. So these I do want, right? Yeah, they all look like things I do want, so I'm going to say just work in progress, fiddling and fixing. Oopsie daisy, validation layer warnings. So can I inline sub-resource range? So you're equal to a vk image sub-resource range, which has aspect mask equal to, and check what it fills in. And yeah, it's color depth. That's one for stencil. So I think color is the right thing. Base MIP level and level count and base array layer and layer count. Can I just check in this? MIP level, yeah. So it doesn't start counting at 1 or something weird. Image view create info. Okay. So image barrier to right. Because these are commands. And they were saying something there about the submission order matters. I wonder if we're just ballsing up our image layout and so it can't write. So we've got that. We can delete this, which means now that other one's going to complain. We'll yank you, put you in there, and let's tweak this now. So we have memory barrier transition to fragment shader output writable, and that's all of you. And then we're going to have a second memory barrier transition to presentable. And my thinking is this is in the wrong place. So we grab all of that. Begin rendering. Command pipeline. Command vertex buffers. We do the draw. We finish rendering. And then we make it presentable. We finish that recording the buffer, or we finish recording our command buffer, we submit our commands, and then we present. It does feel a little bit clutching at straws. I feel like I just keep changing things semi at random, but there is clearly something somewhere. No, so it wasn't that. If I Odin build main debug, and we go look at that, does that also have that clear on it? Not frame, what's it called? Render doc. Let's shunt you off to another page. We reopen it. Let's auto capture the first frame. And we want to go grab this again. We launch. Got our frame. We come back here. We can see, we begin rendering, we draw, we render. Where did I see all of that other stuff? Okay, sanity checking. So when we draw, we can see this, which is good. And if I come into here and I check a random pixel in the middle, it does have the same thing where we see the shader gives it a color. Right, what do we have in here then? We have a clear. Sorry, we have a barrier. We have a clear. We have a right. And then there is no second barrier. Can I see what those barriers are? So you'd have to come back, back, back. What's this saying? So at this point it's done its barrier. How do I see this thing? Right, so it's going from undefined to a cleared thing. How do I see? what layout this is in. There must be a way. Swap chain image, 640 by 180. Sorry, 640 by 480. Hover. Just tells me what position it's at. Right click is the pixel I picked. It's under Resource Inspector. I can see my swap chain image. Ah, that's a point. I'm messing around with the swap chain image. What is it actually doing the rendering on, though? Oh, in fact, I can see it here. So you have a barrier, a discard, a clear, frame buffer color, barrier, derived from swap chain image view, create image view, create info, format BAGA RAAA sRGB, components sub resource range. If you create flag bits 0, so we've not put any flag bits on it. I wonder if the mistake I'm making along the way is something about trying to write this shader output onto that image view. I mean, what else would you do, though? So we can see our shader is working. So everything is working up until the point that we want to send it onto the image that we're going to send to be presented. So what does this actually say? This is saying color pass EID 9. When it begins rendering, it does a clear. Yeah, so that all makes sense. And then it's in color pass number 1, EID 12. So it's in our draw command. Primitive 0 comes out of the shader with the right value. What's this saying here? Preview colors displayed in visible range with RGB channels visible. Double click to jump to an event. Okay, yeah, they're all in the same event. Yeah, I'm not sure. I think I'm going to have to have a bit of a read offline, because I'm not going to clock it, I don't think. Oh, frustrating. But, I mean, it's not all bad news, right? What we've now got is a working graphics pipeline right up until the point we want to present. So we can see that our shader output is working. It's just that last bit where we actually try to show it. Okay, I'll have to have a bit of a read through the docs. I've clearly missed something daft. This is going to be another really silly thing, isn't it? But it is getting late for me now, so I don't think today is the day. we didn't make it in the first 10 videos, which, I mean, is that embarrassing? Maybe that's embarrassing, but you know, the only thing I can think is that we're doing something wrong by trying to write to a swap chain image out of our shader. I don't know what types allow it. I might have to just have another read through some of the docs around dynamic rendering. I mean, I think you can see there when I pull up the Bracky stuff, it is the bit that is meaningfully quite different. So maybe it's not a surprise that this is where this all fell over. But, yeah. Tricky. Rendering attachment info. I'm confused now that I can only see the one of these memory barrier things. Okay, one last idea. What if I put this one for doing the present inside of the rendering, but after all the drawing? Because it says it is a thing that depends on submission order. So let's do a build. No, and it complains because it's going to say you can't change the value within a... Oh, maybe you can. Source stage mask must be dependency by region bit. Dest stage mask is restricted to frame buffer stages. Pipeline stage. Color attachment output bit. If it is called within a render pass instance. Defines an image layout transition from a thing to a new thing within a render pass instance, which is not allowed. Yeah, so that's what I was saying. I think whatever you make it, it's not allowed. Okay, so let's undo that, and we will call it a day. Let's see, is that a change I actually wanted? This is just splitting those two calls. Which I think I do want. Okay, drawing a line under it for today. So, maybe next time, guys. Like I say, I'll have a bit of a poke offline and see if I can find the bit that I've missed. Is it going to be the bottom of pipe business? We're now calling this outside of the pipeline. So it can't be looking at this color attachment. Okay, one last idea. Sorry, let's go do it in CAC, because I'm getting used to doing things in CAC now. Render.odin, we're in here. What if you just say at the bottom of the pipeline, you do all of this, and then we do you inside of the render pass, right? So we're saying, because I think I'm telling it to do something at the end of the render pipeline, but it's not inside a render pipeline, so how could it, right? Oh, I've messed up my white space quite badly. Let's tidy that. Tidy that. Image memory barrier. To go from color attachment optimal to present source at the bottom of the pipe. So we finish our graphic stuff. We do this. We go, let me clear, because I think I'm going to get a validation error. No validation error, because it's not running. Odin run main. Validation errors. Lots of them. Source stage mask is restricted to frame buffer stages only. What if I make it the color attachment out one then? And you are also going to be the same. And then it's going to complain that it needs that dest mask thing on it. Up here, source stage mask must be by region. Source stage mask? Source stage mask. I think it's this one, isn't it? Dependency flags must have that in it. Clear that, run that, still not there. You define a layout transition within a render pass which is not allowed. If this is within a render pass instance, the old layout and new layout of any image memory barrier included in this must be equal. Okay, so it's not that. How's the other one doing it then? Command begin rendering. So that one's happening before. Can I just pass in no stage mask? Is that an option? Okay, can we go? So I don't think I want any of this. So can I just go nuke these changes? Reload the thing. What happens if I just set nothing in these stage masks? And just do like this and this. Odin run main. It attempts. Death stage mask must not be 0 unless synchronization 2 is enabled. Interesting. I don't know what synchronization 2 is. So maybe that's a hint that that's a thing to go look up. Okay, but as is, that doesn't work either. I do think there's something to that though, right? We're saying bottom of pipe. Oi, what if instead of this, this is bottom of pipe? But instead of doing... So, I think this needs to be... It needs to know about this before it gets there. So what if up here... Where am I looking? Color attachment, we do that one, we do that one, so it knows what it's going to be doing. I think we might have just gone in a big circle and got back to where we started. Right, because I think we've just grouped the two together again, which is what I had in the first place. Okay. Let's actually end it there. Right, it's a sad ending. It's not happening today, boys. Like I said, I'll have a bit of a read offline, see if I can work out what I'm missing, but maybe next time. Until then, I guess I hope you've enjoyed, and I'll catch you, hopefully, for a more successful outing. So, see you later.